So let's imagine we're creating a game, and it's going to be a Star Wars game, but the game's going to be kind of weird because the content available to you in the game is going to be entirely OS dependent. So we'll just put the OS here. This is the OS. And I want you to imagine that this is the game running on the OS. So like I said, the content available to you in this game is going to be entirely OS dependent. So it's a Star Wars game, and there's going to be content for both Jedi and Sith. So if your OS is Mac, then the content available to you is going to be the Jedi content. So we'll just outline this in blue for Jedi. And if your OS is Windows, then the content available to you is going to be Sith content. And the part of this game that we're going to be developing for this example is just the character creation part of the game. And the character creation part of the game is just going to involve rendering the accessories for both the Sith and the Jedi. So the Sith accessories are going to look like this. So if you're on a Windows system, the accessories available to you as a Sith are going to be a red lightsaber, a pair of red eyes, and a black robe. And I apologize, it's a bit difficult to see the black robe, but it's there. And if you're on Mac OS, the accessories available to you as a Jedi are going to be a blue lightsaber, a pair of blue eyes, and a white robe. So again, the accessories available to you are OS dependent. So now let's take a closer look at the game. So within the game, the code that we're going to be writing is the code for character creation, or more specifically, character generation, because you're actually not going to be able to choose the accessories for your character. They're automatically going to be rendered based on your OS. And we're going to need to imagine that the game is modular in that the client code that we're going to be writing is going to be completely segregated from the surrounding framework that's going to define the interface that gives us the ability to render the specific accessories depending on the OS. So I know that sounds like a lot, so let me just show you. So we'll separate this game application into the client code and the surrounding framework. So this is the surrounding framework, and the client code is this inner square. Now, when we start this game application, the framework is going to inject into the client code what is called a factory. And the client code is going to use the interface of the injected factory to render the accessories. And I know this sounds really complicated, but I'm going to try and simplify it for you. So just stick with me. So let's just draw out an arrow here, because the things that I'm writing here are going to be part of this framework layer. So this framework layer is going to have an abstract factory class that's basically going to define the interface that's going to be used by the client code. Now let me explain what I mean by that. So there's going to be an abstract class, and that class is basically going to define the abstract methods to create a lightsaber, create eyes, and create a robe. Now, since this is an abstract accessory factory, it's not going to implement these methods. Its subclasses are going to implement these methods. So for this abstract factory class, we're going to have two subclasses. We're going to have the Sith subclass and the Jedi subclass. So I'm going to need to make this a bit smaller. From this abstract accessories factory class, we're going to derive two concrete classes that are going to implement these methods. So the first one we'll do is the Jedi one. So we'll just put a blue arrow here, and this one's going to be called Jedi Accessory Factory. And it's going to extend the abstract accessory factory. And I'm running out of space here, so sorry about this. So it's extending this abstract accessory factory. So it's a subclass of this class. And since this is a concrete class, this one needs to actually implement these methods. So it's just going to implement create lightsaber, which is going to return a blue lightsaber. And once again, I'm running out of space here, so just bear with me. And it's going to do create eyes and return blue eyes. And lastly, create robe, and it's going to return a white robe. And we're also going to do the same thing for the Sith accessory factory. But for the Sith one, we're going to return a red lightsaber, red eyes, and a black robe. So now we have two concrete classes, which means both of these classes have concrete implementations for the methods that are defined in the abstract accessory class. And as you can see, the interface for creating lightsaber and creating the eyes and creating the robe, they're the same for both classes because they both are implementing the methods of the parent class. But the thing that's different is what's being returned, the objects that are being returned. Now, the framework is going to provide one of these factories to the client code, and that's going to just be dependent on the OS. So the framework's basically going to check the system's operating system, and if the operating system is Mac, it's going to provide this factory. And if the operating system is Windows, it's going to provide this factory. So the client code's only going to know that it has an interface for creating a lightsaber, creating eyes, and creating a robe. It's not going to know that that interface is creating either Jedi or Sith accessories. And it doesn't need to know. And it'll become more clear when we get to the code, but let me just explain a little bit more about this. So basically a factory, you can just literally think about it like a factory. Like a car factory produces cars, right? Or like Santa's factory produces presents. So the objects that Santa's factory produces might be a bit ambiguous, but you get the point. A car factory produces cars. A Jedi accessory factory produces Jedi accessories. It's going to create Jedi accessories. That's basically what a factory is. And that factory is going to get passed to the client code, and then the client code isn't going to have to worry about what OS it's on or anything. It's not going to have to know about the underlying implementation details of the framework surrounding it. It's only going to have to know that it has access to this interface, create lightsaber, create eyes, create robe. And then that's all it's going to use. But the main thing that you need to understand with the abstract factory is, if we go back to that definition, it provides an interface for creating families of related or dependent objects without specifying their concrete classes. So the interface that we're talking about is basically this. Let's magnify this client code really quick. So this client code that's inside of this framework, that's this. We just magnified it. Now, from the client code perspective, I don't want you to imagine this top level overview. Like from the client code, we don't know about the implementation details of the framework. All we know from the client code is that we have a factory, and we know that the factory provides the interface to create these objects. So from the client code, all we know is that we can do this: factory.create lightsaber and factory.create eyes and factory.create robe. That's all we know from the client code perspective. So if you know that from the client perspective, all we know is that we have this factory that provides the interface for creating these objects, you might be wondering, what's the benefit of doing this? Well, I'll show you what the benefit of doing this is. So basically, this is our client code. So let's just imagine that currently our client code, we're just creating these items, and that's it. That's the code. Now, if one day, as the creators of the framework, we wanted to provide more functionality to people that use it, aka the client code, if we wanted to provide more functionality to them, they wouldn't need to change their code if we were to, say, add additional accessories. So for example, what if we were to add create blaster? So now we've updated our framework with this new method to create and generate a blaster object. And maybe when we updated that framework, we had to add a new object type for blaster and stuff like that. But the client code, unless we plan on using that blaster, we don't need to change our code. Our code isn't tightly coupled with the framework's code. So as long as the framework continues to provide the interface that we're using, any updates or extensions or additions to the framework aren't going to impact the client code because they're loosely coupled. In fact, we could even change the type of object that's returned by one of the methods that's being called by the client code. So maybe some Jedis have purple lightsabers. So maybe we change the lightsaber object that gets returned for the Jedi accessory factory to purple. So now create lightsaber for Jedi returns a purple lightsaber. The client code still isn't affected by this because the client code is just calling this interface. So it's just going to receive a purple lightsaber instead of a blue one. It doesn't make a difference to the client code if we change the objects that get returned for these methods. If we add additional objects to be returned, we could extend our client code to use, for example, this create blaster, but adding it isn't going to break our client code because they're loosely coupled. So that's the benefit of the abstract factory pattern. And actually there's another benefit. So right now it's impossible for the client code to create any accessory that's not available to its OS. So for example, if this code is running on a Mac, it's literally impossible for this code to create a red lightsaber because Mac is specific to the Jedi accessories. And the factory that's passed to this client code is limited to only the Jedi accessories. Like, we're able to enforce the family of accessories that is available to the client code simply by using this abstraction. So we're able to enforce the constraint of which accessories are available to the client code by using this pattern, because the client code is only interacting with the interface provided by the abstract factory. It has no control over the concrete classes that get passed into the client code via dependency injection. So when you hear the complex sounding definition of provide an interface for creating families of related or dependent objects without specifying their concrete classes, it basically means we're providing the interface. So the interface is available through the factory, right? But that's all that's available, the interface. So the only thing that the client code has access to is this abstract factory's interface. So that's provide an interface for. And then the for creating families of related or dependent objects. Families of related or dependent objects. So this is the Jedi family of objects. This is the Sith family of objects. So for creating families of related or dependent objects without specifying their concrete class. So the concrete class for this abstract factory, the concrete classes are this Jedi accessory factory is a concrete class of this abstract factory class. This Sith class is a concrete class of this abstract factory class. These are both concrete classes. They handle the implementation details of the methods defined in the abstract factory. They're concrete classes. But the client code doesn't know which concrete class it's getting. The client code doesn't specify the concrete class. So that's what the last part means, without specifying their concrete class. The client code just gets a factory. It doesn't know what the concrete class is. It only understands the interface provided by the abstract accessory class. So the client code is completely decoupled from our framework. But anyways, now that we have a general understanding of what the abstract factory class is, let's go over a code example. Okay, so while we're writing this code, I want you to keep in mind the separation of concerns. There's the framework code, and then there's the client code. And actually, I want you to imagine that this framework code that we're writing is written by a completely separate team of developers from the developers that are going to be writing the client code. So right now, we're acting as the developers that are working on the framework code. So we're only going to start by writing out the framework code. And the framework needs to provide the interface to the client code to generate the accessories for Jedi and Sith. So first, we'll just do some imports. And you don't need to worry about what these imports are doing yet. So the first bit of code that we're going to be writing is we're going to write the classes for the accessories. So we're going to start with an abstract class, which we'll just call accessories or accessory. And each accessory is going to have a method called render. So we need to create an abstract method called render. And as you can see here, we're defining this method render that's going to return a string, but then we're just passing, because since this is an abstract method, this abstract class isn't going to provide the implementation for the method. Its subclasses are going to provide that implementation. And the subclasses of accessory are going to be all of the accessories. So blue lightsaber, red lightsaber, etc. So let's go ahead and write out these accessories as well. So as you can see, we have this blue lightsaber class here. And since it's extending accessory, it's required to implement this render method, because any subclass that extends this accessory abstract class needs to implement this render. So we're going to do the same thing for a red lightsaber, and we'll do the same thing for red eyes and blue eyes and black robe and white robe. So as you can see, we now have all of the classes for our accessories. So if we go from the top here, we have the accessory abstract class, and then we have all of the subclasses, the concrete subclasses. So blue lightsaber, red eyes, blue eyes, black robe, white robe. So now we want to create the abstract accessory factory, which is the interface that the client code is going to interact with. So we'll do class. And if you're wondering what this ABC is, we're basically extending this ABC here, which is an abstract base class. And all it's doing is it's making our class an abstract class. So when we use this ABC here, it's going to make it so that when we extend the class here, when we extend this class, any subclass is going to be required to implement its methods. So for example, let me just comment that out really quick. This white robe is extending accessories, right? Or accessory. And accessory has this abstract method render that needs to be implemented. So if white robe doesn't implement that, we should get an error. So maybe we define some random method here. And if we go here, you see we get an error down here. Class white robe must implement all abstract methods. So if we change this back to the way that it was, we see that we don't get that error anymore. So the reason for this green line here is because it expected 2 blank lines after the class above it. So we can just format and that'll fix that. But yeah, so that's what this ABC is. We're extending ABC so that we can make the class that we're creating an abstract base class. And the abstract accessory factory is going to define the interface that the client code's going to be able to use. So we need to define the method for create lightsaber, create eyes, and create robe. Same way as I explained in the explanation. So we'll use abstract method, create lightsaber. And create lightsaber is going to return an accessory. Because remember, lightsaber extends accessory. And remember, this is the abstract class, so we're not going to do the implementation here. So we just pass. And we'll do the same for the other two. So now we have our abstract accessory factory. And we have the interface to create each of these items. So via this abstract accessory factory, we're abstracting the implementation details away from the client code. Client code only sees this. The implementation details are unknown to the client. So now we need to create the concrete classes that provide the implementation for these methods. Now, remember, we're still in the framework code. We're not writing any client code yet. We're only writing framework code. So it's very important that you understand that so you can understand the separation of concerns and why this pattern is useful. So now we'll move on to the class Sith accessory factory. Now this is going to be the concrete class that creates accessories in the Sith family, and it's going to extend the abstract accessory factory. And since it extends the abstract accessory factory, we need to provide the implementation for all of the methods defined in the above abstract class. So we have lightsaber. Since it's a Sith, we'll return red lightsaber, a new instance of red lightsaber. And then we'll have eyes. And since it's a Sith, we'll return a new instance of red eyes. And lastly, robe. And since we're dealing with the Sith, we'll return black robe. Now this is the concrete class for the Sith accessory factory. So now we need to do the same thing for Jedi. And the Jedi accessory factory is going to provide the implementation for all of the same methods, but it's going to return the Jedi accessory objects. So blue lightsaber, blue eyes, white robe. Now at this point, we're almost finished with the framework code. So now we need to go down here and we're going to do if name equals main. Now this part, you don't really need to worry about this. This is just how to create an entry point in Python. Now, what does that mean? It basically means that whenever we run this file, so if we go to the terminal and we change directory to abstract factory and we ls this file is abstract factory pattern.py. So whenever we run this file, this abstract factory.py file, whenever we do python 3 abstract factory pattern.py, this name variable is going to be equal to main. So all that means is that whenever we run this file using the Python command, anything under this if name equals name is going to be executed. So if we do print hello and we save it and we go back to our terminal and change directory abstract factory and we do python 3 abstract factory pattern.py, we're going to get hello to the screen, as you can see here. So that's all this is. It's the entry point. So whenever we run the file, the code here is going to get ran. And this is basically where we're going to initialize our framework and do the dependency injection. So basically, we're still in the framework code. So within the framework code, what did we say that we needed to do in the explanation? We need to determine the operating system of where this game is running, right? So we need to know the current OS, and we're going to set it equal to platform.system. And that's why I imported platform up here, because this platform.system is going to tell us the OS name, basically. So return system OS name, e.g. Linux, Windows, or Java, etc. So this is going to give us the operating system that the game is running on. So current OS is going to be referencing the operating system. So now we can check that operating system to determine which factory we're going to give to our client. So we'll do if current OS equal to Darwin, and Darwin is just Mac OS. Then we're going to give Jedi factory to client. Elif current OS equal to Windows, give Sith factory to client. And lastly, else print OS not supported. Sorry, Linux users, coming soon. So now this is our framework code. So whenever we add classes or add methods here, it shouldn't impact our client. So now I'm going to need you to use your imagination a bit here. So we're going to write the client code in here, but I still want you to imagine that the code that we just wrote is the framework code and it's completely separate from the client code. But I don't want to be creating files and importing packages and such because I don't want to confuse you. So just use your imagination here. We're going to create the client code, but we're just going to create a function called client. And this is going to represent the client code. And this function is going to be void. But this function is going to take in a parameter, and that parameter is going to be the accessory factory, and the type is going to be abstract factory. Now remember, in the explanation, I told you that the client only knows about the abstract factory interface. It doesn't know anything beyond that. Like, I know I'm writing this stuff in the same file, but I want you to imagine that they're completely separate, the client code and the framework code that we just wrote. So here in the framework code, if the OS is Mac OS, we're going to pass the client the Jedi accessory factory. And if the OS is Windows, we're going to pass the client the Sith accessory factory. Now remember, this is our framework code, but from the client doesn't know which factory it got. All it knows is that it has an abstract factory. So its accessory factory, we know the methods available. We know that we have create robe, create eyes, create lightsaber, but we don't know if we're getting Jedi accessories or Sith accessories, and we don't care from this client perspective, because from the perspective of the people writing the client code or the client app, they just need to generate whatever accessories are available to the factory that was injected via dependency injection. So they don't need to create instances of any classes or anything. They don't need to know the underlying implementation. So we could just go ahead and accessory factory dot create lightsaber, create robe, and create eyes. And let's go ahead and name these. So eyes is equal to that, robe is equal to that, and lightsaber is equal to that. Now in our client code, all we're going to do is we're just going to render these items, and we can just imagine that rendering these items shows them on the screen to the player or something. You just use your imagination for this part because I don't want to add too much code. So to render the eyes, we're just going to eyes.render, because remember, all of the accessories had to implement this render method, right? And we'll do lightsaber.render and robe.render. Now remember, this is the client code. It's completely separate from the framework code surrounding it. Just ignore that they're in the same file. So now what's going to happen is when we run this application, when we run this game, it's going to detect that my system is Mac, and it's going to render the Jedi accessories. So if we go ahead and save that and we open the terminal, and let's change directory there again, and then run that, it detects that I'm on a Mac system. So it's going to render blue eyes, a blue lightsaber, and a white robe. And we can make changes to the framework without impacting the client code. This is the client code, right? But what if we said, okay, actually we want Mac OS to be Sith, and we want Windows to be Jedi? What if we did that? Is it going to break our client code? No, it's not going to break anything. It just means that when we run this application now, we're now going to get the Sith accessories because the framework made the change, but we don't need to do anything because they're both completely decoupled. And that is the abstract factory pattern. The implementation details of this abstract factory interface are abstracted away from the client. And yeah, this is a very important design pattern to understand, and I hope that I was able to make understanding this pattern a bit easier for you. But anyways, that's going to be it for the abstract factory pattern. If you found this video helpful, tell your friends, leave a like, subscribe if you already haven't, and I'll see you in the next one.